share. Noda works with AI-based innovation in district heating and cooling. Welcome, Christian.
Thank you very much. It's been very nice being here the last 2 days. So, about 50% of all our energy that we use in Europe is used for heating and cooling. Industrial processes, buildings and so on. Nearly 1/3 of all the CO2 emissions in Europe is from buildings. You know, it's a huge part of thermal processes. And the problem is that if we're going to build a sustainable society, we really need to harness this potential in thermal processes. And it's hard. Thermal processes are really hard because there's a delay in these. It's not like electricity. It's not like charging poles for batteries for a Tesla. You know, the thermal delay. This makes it very hard to model. We've been doing this for more than 15 years now. From an AI perspective, kind of harness this model of the thermal process. Now we're working district heating, district cooling, heat pumps, gas. We are about 10 people now employed at Noda, and we have Noda tech deployed in more countries than we have people employed at Noda. So we do business in China, Europe, North America now. And we also see now in the UK, it's very exciting because you also have a large challenge here, like everyone else, with the gas prices, electricity. We really need to do something about this. The only thing you can do on a large scale is to harness thermal processes. And that's why we're here. And what we're looking for, last year we did the first round of investments. Now we're looking for a second step. We're looking for partners, resellers, people that can help us grow business. We've done it all over the world. What can we do here? That's why I'm here.
Thank you, Christian.
Christian, it probably won't be a surprise for me to ask about benefits, given what I said a minute ago, but it'd be interesting to understand the kind of savings that your solution's delivering in terms of optimization of heating.
If you just look at normal building, social housing, gas, 15–20%. If we talk more, look at large scale district heating networks, it depends on the setup, but normally it's more about reducing the dependence on fossil, but also increasing the capacity of renewables, because there's a switch, you know. It's not, you can't just leave the fossil and go directly to renewables. It's also this transition that will help by increasing the capabilities of renewables while reducing the dependence on the fossil. So we have these hybrid systems, low temperature systems. They need to be balanced. How do you balance them? Because you have a good model for the thermal process.
Sorry, I've got a second question. I find this one of the biggest challenges for us in decarbonisation in the UK is heat, and you know, it will continue to be a challenge for the next 10–15 years. Can your AI, can your thermal processing unit also look at the differences between different housing stock and different types of buildings, and provide effectively insights as to how to optimize? You know, if you were to look at the construction, the layout of a building, compare and you know, look at the heat performance, thermal performance of that building, could that be used for informing design in the future?
Yeah, not so much the design of the building itself, but rather how you use energy.
So ask Cam. Sounds like you guys should chat.
One of the part of system, it's not just controlling stuff, but also analysing before you do things. Before you have surgery, you have a health check. You know, someone checks your blood pressure, AKG, things like this. You know, so we do all these things, the blood pressure and the surgery. So yeah, we do these things large scale. You look at the whole city, try to find where do you get the most bang for your buck if you want to do control things in a better way. You do that over here, and also you analyse what's the benefit of doing it from a financial perspective. These things is very important also.
Thank you, Christian.